Hello, I'm feeling a little under the weather today, but I am not sick enough to miss out on an opportunity to talk about conversion factors and dimensional analysis. We'll talk about dimensional analysis in a few slides here. I'll write it up here. But, of course, to introduce this topic, we have one of the great conversion factors of comics, and that is the phone booth. As you can see here, Clark Kent comes in a regular businessman and comes out Superman. So now we'll try to figure out how to do this something similar when it comes to our units in chemistry. How do we start with something we don't want and end up with something we do want? You'll see that it's almost magical the way you go about this. But we have to start with, first of all, a conversion factor is a ratio of equivalent measures. Okay, so let me just, I know that sounds a little bit, a little bit unusual, so let me just give you an example. Here's a conversion factor, 12 inches. Let's put that in. 12 inches equals 1 foot. That is a conversion factor. It's that simple. A ratio of equivalent measures. Okay, so that is an example. You'll find that we can use that to really solve problems, as even complex problems, just knowing simple conversion factors as long as we go step by step. Okay, so here's an example. 1 meter equals 100 centimeters. Let me take you through a few steps to help you understand conversion factors. Let's take the example of 1 meter equals 100 centimeters. Okay, something simple that we can do to this, as you know, is we could divide both sides by 100 centimeters. All right, I'm just going to show you what happens with this. All right, well, there you go, 100 centimeters. Okay, that will make those two numbers cancel out, and you get 1 meter divided by 100 centimeters equals 1. Okay, now you know that's true as well, because 1 meter and 100 centimeters are the same measure. They measure the same length. Okay, so 1 meter divided by 100 centimeters would equal 1. It makes intuitive sense, even though it's a little funny the way it's shown there. Let's look at the next example here, and the point here is that you can do just the opposite. You can divide 1 meter by 1 meter. That's going to equal 100 centimeters over 1 meter, and that will also equal 1. Okay, so 1 meter over 100 centimeters equals 1. 100 centimeters over 1 meter equals 1. Now, there's something important about this number 1. What's so cool about number 1 is that when you multiply a number by 1, it doesn't change the number. Okay, it doesn't change. So if I multiply any number in the world by 1, it will still be that same number. Okay, so in a way, and this is what is unique about conversion factors, in a way, when I multiply something by 100 centimeters over 1 meter, that is the same as multiplying that by 1. And that is okay to do because it doesn't change the underlying number or the underlying value. Conversion factors then are essentially just a unique way of writing the number 1. And I know that sounds different, but when you have 100 centimeters over 1 meter, that is the same as saying the number 1. They always come in this type of format. You always have a big number with a small unit equals a small number combined with a big unit. All right, so let's look at how this comes together. We have 100 is the big number. Centimeters are a small unit. Of course, centimeters are much smaller than meters. We're totally aware of that. Equals 1, which is a small number, and then meters is a larger unit. Okay, and it always comes in that format. All right, so we want to practice really quickly, just writing a couple of conversion factors. All right, so we want to come up with some conversion factors. First of all, come up with a conversion factor between kilograms and grams, and also between feet and inches. Go ahead and do this on the side, and then come back and we'll work through it. All right, let's first of all do kilograms and grams. So we have 1 kg equals 1,000 grams, okay, because kilograms is, kilo means 1,000, 1 kg equals 1,000 grams. Okay, so we're going to create a conversion factor. All we have to do is divide both sides by 1,000. and then we're going to get 1 kg over 1,000 grams equals the number 1. Okay, that's one conversion factor. And of course, the opposite, I'm not going to work through the whole thing, but the opposite of that would be 1,000 grams divided by 1 kg equals 1. Okay, the number on the top, the number on the bottom mean the exact same thing. Therefore, if we divide the number on the top by the number on the bottom, we are going to get the number 1. Okay, feet in inches. This is pretty easy. Everybody's very familiar with this. It's not something you're going to use in chemistry because it's not one of the SI units, but it's good to know. You might use it just for practice, but really you're not going to use feet and inches in any serious experimental measurement. But we know that 12 inches equals 1 foot. We divide both sides by 12 inches, and this will equal 1. And we get 1 equals 1 foot over 12 inches. Something very critical is you always have to have your units in these problems, or they will make 0 sense. Obviously, 1 divided by 12 on its own does not equal 1. But 1 foot divided by 12 inches does equal 1. That is a conversion factor. The converse is also true. 12 inches over 1 foot equals 1. All right, we've got one more problem we want you to work out. Let me get some erasing here. Last problem is, or maybe 1 or 2 more problems. Okay, we know that 1.096 quarts equals 1 liter. On the side, please turn that into a conversion factor. Okay, welcome back. We already know how this works. It's actually getting to be pretty simple. Okay, when we know that one measure is equal to another measure, all we essentially have to do is put 1.00 liters over 1.096 quarts equals 1. Okay, so that's a conversion factor. The converse is also true, or the inverse is also true. Right? We could put the 1.096 quarts on the top and 1.00 liters on the bottom, and that would also equal 1. Okay, now we've got to talk about why we're learning conversion factors. Okay, it's almost kind of become kind of obvious now what a conversion factor is. If one measure is equal to another, if we put one on top of the other, then it essentially equals 1. That makes sense. Any number divided by something that's equal to it is going to equal 1. All right, so what are they good for? All right, now that we've established these conversion factors, okay, this is where we really see how we can take the common unit and turn it into super unit by using conversion factors, and this is what they're valuable for. Essentially, you start with what you don't want, you end up with what you do want. So here's what we can do. We can multiply by the number 1 to creatively change the units. Okay, so by multiplying by the number 1, which instead of the number 1, we're going to use those ratios that we came up with, which we know equal 1, then we can creatively change units. So we might have a unit that is in weeks and we want it in minutes, right? There's a way that we can do that by using these conversion factors. That's what they're useful for. Okay, here's an example question. 13 inches is how many yards? Okay, now that seems like a headache. Okay, when we do it the old way, it seems like a headache. It's like, okay, 13, we've got a lengthy way where we've got 1 foot is 1.2 yards. We got this lengthy process we could go through if we didn't have this new method to work through these. So here is what we do. First of all, we look for a conversion factor, right? We want to look for an equivalence that includes each of those units. And we know that 36 inches equals 1 yard. All right, so here's what we do. Then we create a conversion factor. Okay, 1 yard divided by 36 inches equals 1. If you're wondering how that works, it's the same thing we've been talking about. We divide both sides by 36 inches. Divide this by 36 inches. And then, of course, those will cancel out, and we'll get 1 yard over 36 inches equals 1. Okay, then here's what we do. We start with what we're given, okay, which was 13 inches. We multiply it by a conversion factor. And here's what's handy. If we've got inches on the top, that cancels out with inches on the bottom. And then we're left with yards is the only units we're left with. So that means our answer is going to be in yards And all we do is we take 13 divided by 36 equals 0.36. Let's talk now about dimensional analysis. Dimensional analysis is essentially what we just did when we converted 13 inches to yards. And dimensional analysis is a way of multiplying by 1 or multiplying by those conversion factors in order to get from units we don't want to units we do want. What you'll find is that you can use these simple steps to solve some pretty complex problems. Let me give you a metaphor as a way to think about this. 2 years ago, I was reaching for something at the top of my closet. I pulled it down, and along with it came a bucket of paint. Now, this wasn't just any paint. This was appliance paint. It's meant to paint things like ovens and endure extreme temperatures without wearing out and without chipping or anything else. So as you can imagine, appliance paint is extremely strong and very difficult to clean up. And I had just spilled it on our new wood laminate floor. And so I was in a situation where I had to clean this up very quickly. Here's how it worked. Okay, I started with spilled paint. And what I wanted was a clean floor. And when you do dimensional analysis problems, you'll do this exact same thing. You'll put down what you're given on the left-hand side, what you want on the right-hand side. Now, let's see what I did. Okay, first of all, I'm going to multiply this by a conversion factor. This conversion factor is paint thinner and when we put paint thinner there, we get rid of spilled paint. Ah, awesome. I just canceled out spilled paint. That was something I did not want, but look, I'm now left with paint thinner. Do I want paint thinner? No, I want a clean floor. That's my goal. Let's see what else I can do. Okay, I'm going to try to put soap, which gets rid of paint thinner. Okay, so cancel out paint thinner. We're left with soap. Okay, now do I want soap on my floor? No. What I want to do is I want to use water to get rid of soap. Ah, good. Cancel that out. Okay, but now I'm left with water on the floor. 2 more steps. Don't worry, we'll get there. We'll use a towel to clean up water. And then we pick up the towels. So put towels on the bottom to result in a clean floor. Let's try this again. A clean floor. All right, let's do that final cancellation. And now we have ended up with exactly what we wanted, which was a clean floor. All right, that was the conversion factors I had to use to clean up paint. We're going to use a similar idea when we clean up units that we don't want to get to units we do want. Let's look at some examples. All right, how many minutes are there in exactly 1 week? Okay, I'm going to work this one out, and then don't worry, you're going to do the next one. All right, so let's go through how we do this. What is our goal? We always write our goal on the right-hand side. Our goal is minutes. Okay, so let's put minutes over here on the right-hand side. What are we given? Exactly 1 week. Okay, so they're saying start with 1 week and figure out how many minutes that is. All right, so we're going to put 1 week on this side. Now, we don't have to make it this far apart necessarily. Sometimes it'll take less than this much distance. But we are going to use conversion factors in order to get from 1 week to minutes. That's our goal. All right. What can we multiply week? Because we want to get rid of week. That's not what we want. So we know that there are, let's try this, 7 days in 1 week. Ah, good. Cancel that. What's another conversion factor we can use? Oh, okay. We know that there are, see, this is not too bad. You guys can obviously do this. How many days how many hours are there in a day? 24 hours in 1 day. Okay, so now we've canceled out days. Okay, but we're stuck with hours. That's not what we wanted. We want minutes. That's what we're going for. Okay, so let's stop messing around. Let's see if we can get to minutes. We've got 60 minutes in 1 hour. Aha! We have completed our dimensional analysis. All we need to do now is the calculator math. Okay, so we just need to we need to look at all of our numbers here, and everything on the top we multiply, everything on the bottom we divide. Now the bottom in this problem is pretty easy because they're all ones. 1 times 1 times 1 times 1, not a big deal. So really all we need to do in this problem, sometimes we will need to divide by something, but in this problem we just need to take 7. I'm doing it on my calculator because I'm not able to do this in my head. We just need to take 7 times by 24 times by 60 equals 1080. So 10,080 minutes in 1 week. That is our answer. And that is dimensional analysis. The way we did this here, it doesn't get much more complicated than that. It gets a little bit more complicated, but not much. If you can manage a problem like this and take it step by step, just like I had to do it when I cleaned up my paint, you'll be able to solve any dimensional analysis problem you want to. All right. Now, here's your problem. Do this on the side. Maybe it's slightly more complicated, but not really. And use conversion factors to get to your answer. And then we'll come back and work on it. Okay, hopefully you nailed this problem. Whether you did or not, we'll go through it really quickly. Let's see here. An experiment requires that each student use an 8.5 centimeter length of magnesium ribbon. How many students can do the experiment if there is a 570 centimeter length of magnesium ribbon available? All right, now this is a little bit different, all right? It's not the traditional straightforward conversion factors that we normally use. Instead, you kind of have to create a conversion factor on the fly, okay? So, what are we given, okay? We are given a 570 centimeter length of magnesium ribbon. Okay, now what do we want? We want to know the number of students. So we want to know the students that can participate. So we want to know the number of students that can be accommodated by 570 centimeters of magnesium ribbon. Okay, let's see what we can do. Excuse me. All right, let's see how we can go about this. Okay, so we start with 570 centimeters of this magnesium ribbon. All right, we know that one student needs to have 8.5 centimeters of ribbon. Oh, cancel out centimeters. We're already done. It wasn't too bad. I mean, it looked weird from the problem, but it really wasn't too bad. So all we do is take whatever's on the top, multiply it, whatever's on the bottom, divide it. So we've got to do 570 times by 1, which of course is just 570. And then we have to divide that by 8.5, and we get 67 students. So 67 students are going to be able to participate. All right, converting between units. Measurements with one unit converted to another equivalent measurement with another unit are easily solved using dimensional analysis. Okay, here's the example, and this uses a funny measurement called a decigram. Okay, and a decigram is essentially 1/10 of a gram. We know about centigrams or centimeters is more common, but decigram is 1/10 of a gram, which means, here's what I'll tell you, and this is something you'll need to learn. There are 10 dg equals 1 gram. There's 10 decigrams in a gram. All right, so with this information, with that little help, I want you to figure this problem out. Okay, welcome back. Let's see how to do it. We are given 750 decigrams, and we want our answer in grams. All right, so all we do is we take 1 gram on top divided by 10 dg on the bottom. I just like to put parentheses around these myself. Okay, sorry about this little thing, it's really annoying. Let me try this again. 10 dg, there we go. This is really simple. Okay, so 720 decigrams divided by 10 grams equals 75 grams. Let's see here. All right, let's do a few more of these. These are fun ones. So on this one, we have to convert 0.44 kilometers to meters. Go ahead and work out letter A on the side. Actually, you know what? Since we're in the mode, do all 3 of these, and then come back and we'll work through all 3 of them together. Okay, welcome back. All right, let's just go through a method on how we can do this. Okay, we start with 0.044 kilometers. And our goal is, you can even put an equal over here, meters. All right, so how do we get from kilometers to meters? Let's see here. Is there any relationship we know between kilometers and meters? Well, let's look at this. Kilo means 1,000 meters. Okay, so 1 kilometer must equal 1,000 meters. Aha, and all we do is we put, let's see, we want to put 1,000 meters on the top and 1 kilometer on the bottom, and that is going to equal 44 meters. And you'll notice here, if this conversion, and this is not uncommon at all you do is move the decimal 3 times over. Now you could just multiply it as well, but you'll learn very quickly that if you're multiplying by 1,000 with 3 zeros on it, you move the decimal 3 times over, and that will be your answer. All right, milligrams to grams. Okay, start with 4.6 milligrams. Our goal is grams. Move that over a little bit so we have some space to draw it in there. All right, now that is a good question. How many milligrams are there in a gram? Okay, well, milli means 1/1000th of a gram. Okay, so if milli is 1/1000th of a gram, then how many milligrams must there be in a gram? Okay, that's probably correct. There's 1,000 milligrams equals 1 gram. All right. Now you could have written this differently just so you're aware, because milli means 1/1000th. You could have also written it 1 milligram equals 0.001 grams. All right, that would mean the exact same thing, because we divided both sides by 0.001, then we would get 1,000 milligrams equals a gram, and so it comes out to be the same thing, just so you're aware of how you can do those conversions. All right, so now all we do is we take this, we're going to take this equivalence, and we're going to say, let's see, which one do we want on the top? We want to have grams on the top because that's our goal, so we're going to put on the top 1 gram, on the bottom 1,000 milligrams, and then we cancel out. Now you always want to do this. We didn't do it up here. We blew that. You cancel out your milligrams, and you are going to get, okay, so if you're going to divide, dividing by 1,000, let's try this. 1, 2, 3. Okay, and that is our answer, 0.004 grams. All right. Now, we want to take 0.107 grams to centigrams. All right, centigrams, that's a term we don't use that often, but we do know centimeters, so we should be able to figure it out from that. All right, so we've got, start with 0.107 grams. Our goal is, I'm going to put a little equal sign here, centigrams. All right, what do? We need to come up with a conversion factor. How do we get from grams to centigrams? All we need to do is figure out how many grams there are in a centigram. So 1 gram, it's just like a centimeter you can think of. Okay, centi means 1/100th. Okay, so we could say 1 gram equals 100. Now I put an extra 0. 100 centigrams. I'm just going to put CG there. All right, now let's see if this works. Okay, so we go, do we want the 1 gram on the top or the bottom? Okay, we want to cancel, so we definitely want it on the bottom. And on the top, we're going to put 100 CG, cancel, cancel, and then we get our answer is, oh, times by 100. That's going to move the decimal place twice to the right. That means it's going to be 10.7. I'm sorry, just 10.7. We've already got the units there, centigrams, or CG. 10.7 is our answer.